back again. So we are in chapter 2, examining the circuit elements and their definition relation, and we mentioned the ideal elements in 4 groups: sources, resistors, open short circuit elements. Now we are going to classify these elements in 2 groups, or in 2 different groups. So it is in, if we go inside, linear nonlinear elements and active passive elements. What is this linear elements? If an element definition relation is a linear with respect to circuit variables, not time, then this element is called linear, otherwise it is called nonlinear. Let's examine a function when we call a function is a linear function. So this is a y f x. So for the x1 value of x, you're going to get y1. For x2 value, you're going to get y2. So we are saying if we apply x1 plus x2 to this function and find that the already single input related output summation is equal to this one, then it is called linear. So for example, if you write a y equal mx function, that you're going to see that it is true for this property. So that means this function is this type of function. So you could do it and give some examples. You could do it. You're going to consider a line of which function is y equal m times x. So this is a linear function. So if you look at this resistor now, it is like this. Vt, consider this one m, and this is it, the other variable. As I said here, I put a bit stress on it, saying that definition relation is linear with respect to circuit variables, not time, I said. Here you are, this is one of the circuit variables, this is another circuit variable. You can consider this as y here, and r a constant, and that it as x. So y equal m times x. So this is a linear function. So this linear function represented, which is this linear function is the definition relation of a resistor, then that resistor is a linear element. So give you a nonlinear example. Here you are, it is equal r times v square. If it is like that, so this is the definition relation of diode element, and this is not, this function has not that property, that's why it is a nonlinear element. So we will not use nonlinear elements analysis in this course. Within the course, you're going to see those elements in electronic courses and a different type of analysis that you're going to apply. So we know then how we are going to classify our elements as linear or nonlinear elements. So in here we could say that in the previous dependent sources, 4 of them, they are all linear elements, and resistor is also a linear element. So the other classification come to this, so you could see it together, nonlinear and active passive elements. So how we are going to classify the elements as active and passive? If an element energy is always positive, is always, that's very critical word here. For any t, this is another critical word here, for any t, not for some t, but any t value, then this element is called passive. Mathematically, that's the energy. This energy for all t is going to be bigger or equal to 0. So you can transfer this information to the power, saying that integral of Vt times It from 0 to t is going to be is going to give you energy. This energy is going to be always positive. Now we could give you an example for this a passive element. A resistor is a passive element because resistors power is going to be voltage time IT. If you write the definition relation of this element, you're going to end up with that relation. That relation tells me this is always positive, that power is always positive. Why is that? Because I already know that R is always positive, and the I square is going to be always positive even if the I is negative. Square of it is going to make it positive. So this is always positive for all t's. Then the integral of a positive function is going to be positive. So that means for all t's, that energy is going to be positive. That's why this element is called a passive element. Resistor is a positive element. Independent and dependent elements are active or passive. So we've got the thing about here. It says hint, solve parallel connected voltage source and a resistor circuit. So you're going to see, maybe you don't know some of the axioms of this theory, you might not do it, but when you learn it you could do these. But in general we could say that all the independent sources, in general, they are active elements. Dependent sources, it depends, sometimes it becomes active, sometimes, depending on the circuit it is connected to. It could be active or passive, so you cannot generalize it always active or always passive. So if you look at the whole picture once more, so under the name of, in chapter 2, under the name of circuit elements, we have seen the definition relation of the ideal elements, which are sources, resistors, input, open and short circuit elements, and then we classify those elements as linear, nonlinear elements and active, passive elements. That is the end of it.